All right, so what you're going to need to do is you're going to need to have your notes out. And I had told you needed to go through the rest of those notes. We got through, I think we got through about right there, looking at the relationship between volume and temperature. So then you need to look at combined gas law, and that's just a relationship that looks at both Boyle's and Charles' law together. Okay, and then if you look at the examples, what you're going to do in the worksheet is you're basically just going to do some algebra. You're going to plug in the numbers into these equations and solve for an equation. So if we use this as an example, we'll have, let's see, let me round that. So here is our equation, P1 V1 over T1 equals P2 V2 over T2. And then what you'll do is you'll take the numbers that they give you and solve for the unknown. So if this particular example, we have a cylinder of gas that's kept constant at a constant volume as temperature increases from 24 degrees Celsius to 326.4. The initial temperature is 1 atmosphere. What is the final pressure? So we are looking for final pressure. That's going to be the second one. Okay, 1 would be the initial stuff, 2 would be the final stuff. So we're looking for P2. So we're just going to use algebra and we're going to get P2 by itself. That's all we're doing with these problems. It's this simple, basic algebra. Okay, so if we look at what's done to P2, we're going to do the opposite. So we are dividing P2 by T2, which means I'm going to multiply both sides by T2. Let's do it this way. There we go. Okay. And then, so that gives me P1, V1, T2 over T1, P2, V2. Okay. Then I need to get rid of the V2. So I'm going to divide both sides by V2. Okay. So now that leaves me with P2 equals P1, V1, T2 over V2 and T1. Okay, so once I have that solved for P2, now I just have to put the numbers in and I'll get my answer. Okay, so I need to go back and look at what those numbers are. And remember that I told you these have to be changed to Kelvin. These temperatures have to be changed to Kelvin. And we do that by adding 273. So I'm going to take 24.1 plus 273. And then I'm going to take 326.4. And I'm going to add to 273. And if I do that, that gives me 297.1. And then 326.4 plus 273 is 599.4. Okay, so those are my Kelvin temperatures. This is T1, this is T2. Okay, and so remember that equation that we solved for. P2 is going to equal V1 T2 P1 over T1 V2. And so again, the ones are my initial things. The temperatures are, the twos are my final things. So if I go back and look at the rest, those are my two temperatures. I have 1.1 atmospheres, and it says the cylinder has a constant volume. So if it's a constant volume, those numbers fall out because they're going to be the same. So this is going to be 599.4 Kelvin times 1.10 atmospheres divided by 297.1 Kelvin. My Kelvin temperatures cancel out, and then I just do the math. 599.4 times 1.10 divided by 297.1. That gives me 2.2 atmospheres. Okay. And that's it. That's all we're going to do. So let's check the work on that one. Okay. Oops, wait a minute. That's the wrong thing. That's the wrong problem. So they're solving the equation first for P2. They're plugging in and dividing. Okay, so that last step, the problem asked for millimeters in mercury. Let's go back up and look at the problem itself. Yeah, the problem says, what is the final pressure in millimeters of mercury? So we did everything we needed to do to get the atmospheres. Make sure that was right. Oh, here's what I did wrong. This is not 1.1, it's 1.01. So again, 599.4 times 1.01 divided by 297.1. There we go. That gives me 2.04 atmospheres. And then we're just going to use a unit multiplier to convert atmospheres to millimeters of mercury. And that unit multiplier is in your notes. Okay, 1 atmosphere is equal to 760 millimeters of mercury. So those cancel out. I'm just going to multiply that by 760, and that gives me 1.5 times 10 to the third millimeters of mercury. And I rounded it to 1.5. Okay. So go back and look at this. So that's how we use combined gas law. We just plug the numbers in. That's all we're doing each time. So here's another example, but this time we're changing the volume. We're keeping the pressure constant, but we're changing the volume. We're going from 1.1 liters to 0.86 liters, and the initial temperature was 21.8. What's the final temperature? Okay, so I am going to have the same setup. So let's see, let's clear that off. Okay, I'm going to use the same equation. So P1, V1 over T1 equals P2, V2 over T2. Now, this time I'm going to plug the numbers in first because maybe you like doing it that way better, and that's fine. This is all just about algebra, and the same algebra rules apply. The only thing that's going to be different is that temperature, you got to add 273 to it. Other than that, it is no different. Okay, this is just algebra. All right, well, if I'm keeping pressure the same, I'm not changing the pressure, then I can cancel it out. Okay, all I'm doing is changing the volume and the temperature. Well, my initial volume was 1.150 liters. My initial temperature is 21.8 plus 273. 1.8 plus 273 is 294.8. My new temp volume is 0.860 liters, and I'm looking for my new temperature. Well, again, I'm looking for T2. I want to get T2 by itself. All right, well, to do that, you do the opposite. Okay, so if I want to get T2 by itself, and it's down here in the bottom, let's multiply both sides by T2. Those cancel out. That leaves me with T2 times 1.15 liters divided by 294.8 equals 0.860 liters. Okay, again, I don't like having stuff in the denominator. We always want to get rid of that denominator first. So we're dividing by 294.8. Why don't we try multiplying by 294.8 to get that to cancel out? Boom, boom. Oops. Where did it go? Where did my Jamboard go? Oh. Come on. All right, well, we'll start over, I guess. Doggone it. Okay, so our pressure stays the same, so it gets canceled out. So 1.150 liters divided by 294.8 Kelvin equals 0.860 liters divided by T2. So remember, our pressure isn't included because it cancels out. We're at a constant pressure. So I'm just doing the algebra for this, guys. Cannot catch a break here. All right, so then I'm going to have T2 times 1.15 liters divided by 294.8 equals 0.860 liters. I don't like having a denominator, so I'm going to multiply by 294.8. Those cancel out. And if I multiply those two things together, times 0.860, that gives me 253. Okay, and then to get the T2, again, my last thing is to, since I'm multiplying by 1.15, I need to divide by 1.15. So my liters cancel out, and I got 253.528 divided by 1.15. And that gives me 220.46 Kelvin. Okay. So again, my p's cancel out because I'm at constant pressure. I plug in all my numbers. And they went ahead and rearranged first. This person likes to do that and rearrange the letters first. You do it however you want. It doesn't matter. It's all the same as long as you follow regular algebra rules for solving for an unknown. And it is 220K. They went and turned that into Celsius. Your original problem did not say it had to be in Celsius. It just said, what's the final temperature? So I would leave it as Kelvin. That's all you have to do with all of these. So if you look at the worksheet, okay, that's all you're going to do. So in that first worksheet problem, you're going to identify, that's the biggest thing, is identifying what is what. Volume is always liters. So our volume is going to be 1.62 liters. V1, it's the first one listed. Total pressure inside a 1.62 liter cylinder kept at 35 degrees Celsius is 1.1 atmospheres. So T1 is the cylinder size. V1 is the cylinder size, 1.62 liters. T1 is going to be the temperature, which is 35 plus 273. And then P1 is going to be 1.15 atmospheres. If the volume of the cylinder drops to 0.74 liters, that's my V2. I changed my volume. And the temperature remains the same. So T2 equals T1. What is the new pressure? So P2 is what I'm looking for. So that's what I suggest doing. Just make you a list of what you have and what you're asked to find. And then you're always going to plug it into that equation. Okay, so this time our temperatures are held constant. They're not changing. Okay, so they're the same. So all that's changing is my V1 and my P1. Okay, so we plug into that, and that should give us our correct answer. Once you do the algebra part, that's going to give you your correct answer. Let's see. Okay, so again, the T's are not included because the T is held constant. And you're solving for P2. So if you have P1 times V1 equals P2 times V2, because again, our T's have canceled out, if I'm going to solve for that, I just need to divide by V2. Put in all my numbers and get my answer. And that's all you're going to do each time. Okay. No. All right, so every time you're plugging into the same formula, putting the numbers in, adding 273 to all your Celsius, because that's going to give you your Kelvin, and solving for the one unknown. This is basic algebra 1. Okay? All right, hope this helps.